Let's think about the units typically used in the metric system to measure an object's weight. And I'm putting the weight in quotation marks right over here because the units I'm going to talk about are actually, if we wanted to be technical, they're units of mass. And as we'll see later on in our scientific scientific careers, that weight and mass are not the same thing. They are related. Mass you could view as how much stuff there is. How much substance does an object have? How hard is it to change the velocity of an object? While weight is, what's the force that gravity is pulling down on that object? Now, in everyday life, if we're just on the same planet or the same part of the planet, if something has more mass, it's going to have more weight, and if something has more weight, it's going to have more mass. And that's why in everyday language, these words are often interchanged. Later on, we'll see that these mean different things. For the sake of this video, because we're really just getting ourselves warmed up with some of these units, I will use these interchangeably. I'll use them in kind of the everyday language sense, not in the technical physics sense of the word. So in the metric system, when people talk about measuring relatively light things, they will often use the gram. And to get a sense of things that weigh a gram, one example is a paperclip. Your average size paperclip would weigh about a gram. A stick of chewing gum, not even the whole pack of chewing gum, just a stick of chewing gum would weigh about a gram. A dollar bill would weigh about a gram. So this really isn't a lot of weight. Now, if you wanted to measure things more on, I would say, a human scale, you could then increase by a factor of 1,000 and go to the kilogram. And as the unit implies, as the prefix implies, I should say, kilo, 1,000. This means 1,000 grams. And if you want to think about how much that represents, well, many people will measure their weight in terms of kilograms. So I, for example, weigh about 70 kilograms. And I'm 5'9", and I'm of about average build, and I weigh about 70 kilograms. If you want to imagine what a kilogram is like, imagine taking a liter of fluid. Or a liter of water. So if you took a liter of water, and a liter you could imagine as a 10 centimeter deep cube, 10 centimeters wide, and 10 centimeters high. If you fill this up with water, the weight of that thing is going to be 1 kilogram. And things, I know you're not used to walking around with 1 liter cubes of water. Another way of thinking about it, if you go to the supermarket and you were to buy a 2 liter of soda, and sometimes you can buy 2 liters of other things as well, water, whatever. If you buy a 2 liter of soda is going to weigh, well, actually 2 liters of water in particular is going to weigh. Soda has other things in it, so you can't be as precise with the weight. But 2 liters of water, I should say, are going to weigh exactly 2 kilograms. If we don't, and we're just talking about the water itself. We're not talking about the container. But if you want to get a rough sense for how much weight that is, that's going to be 2 kilograms. So if you're measuring, human scale size things, reasonable size quantities of fluid objects around this scale, kilogram makes a lot more sense. If you measure these very light things, you're talking about a gram. If you want to get really precise, this might be more in things of if you're doing, a drug dosage and you need to be very, very, very precise, then you will sometimes see people go to the milligram. But you can imagine a milligram is 1,000th of a gram. And so 1,000th the weight of a dollar bill or 1,000th the weight of a paperclip, this is very, 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 very small. So this usually doesn't come into play in our everyday life.